Hey, and welcome to the Private AI Lab, the podcast where we experiment, explore, and debate the future of AI behind the firewall. I'm your host, Johan, and every month I have a guest in the lab to break down real world use cases, challenges, and innovations shaping private AI. In this episode, Vincent Tsugranes from Red Hat will join me to talk about Red Hat OpenShift AI specifically for the healthcare industry. Enjoy the episode. You can see the red lighting behind me because I have someone in the lab who, has something with red. So it's the one and only Vince Tsugranes. Vince, welcome to the show. So
Thanks, Johan.
For the people who don't know you, who is Vincent and what do you do on a daily basis?
So I'm a chief architect at Red Hat, and I talk to customers all over the spectrum. I'm also a small farmer. So I've got horses, and I live on 20 acres in the U.S., or what you'd call about 8 hectares.
Oh,
So I
dude.
also have like a personal interest in agriculture technology, and look forward to robotics taking some of the labor.
And is that so like obviously you're in the private AI lab, so we're going to talk about AI stuff, but is any of the, like what you see on a regular basis at trade shows or at meetups is people talking about stuff they did with sensors on farming equipment and pulling in data and doing some really awesome stuff with that, like you being active in the field of AI. Is that like, is there some tinkering happening in your day-to-day basis?
Ag tech is its whole own field and subspecialty, right? With robotics and AI embedded, and it's in some ways not that different from the future of where we're going to use AI in healthcare, right? We need things that work offline. Need things that work in all kinds of crazy conditions, and
Well,
it's
well,
yeah.
well, you mentioned AI, you mentioned healthcare, and that's the theme of today's episode. But before we dive into that, I definitely like to know something from you. And I always have the icebreaker in the show, and this time I kind of chose for something around your first, the first time you met or you saw something around AI and thought like, this is going to fundamentally change my career or like the things that I'm doing or something like. So when was the first time you saw AI doing something and you got that spark?
Well, I'd say for probably the last 25 years or so, I've always kind of known that we were on this exponential curve with computing, right? So I remember reading The Singularity is Near, right when I was like first starting my career and realizing, all right, well, if Moore's law keeps pace, right, eventually computing is going to have the capacity to do things that humans do. Between that and like rampant age discrimination in technology, I always kind of assumed that like my career would have a shelf life before I was replaced. Right. So it's something that's always kind of been on my horizon. I do think it's accelerated in the last couple of years in like the public consciousness. I think it was in like say late 2022 when ChatGPT came out that we really like kind of passed the Turing test, which was traditionally the benchmark for AI. And that's kind of when we started calling it, instead of machine learning or data science, right? Just people actually talking about AI, and now it's a daily and an hourly conversation all over the place. So it's really proliferated culture.
Oh, and that's definitely one of the questions I'll follow up with you as well, because like especially in the field of healthcare, we've been doing AI for, well, I would say ages, but for a really long time. And we never called it AI, it was always machine learning, computer vision, it was deep learning, and now all of a sudden everything is being called AI because, well, it requires GPUs, it runs a model, and so this is definitely something that's really interested because before the conversation You mentioned that you've been an internal IT practitioner as a customer of Red Hat for a while in the airline industry and in healthcare before. That perspective is incredibly valuable. So, let's move into what you're seeing now. What is it actually that you're seeing now from that other perspective?
Well, so I think first it's acceleration. I don't think we've ever had a time where technology has gotten simpler, right? So things are getting increasingly complex, running not only on premise but in the cloud, right? And in all of these hybrid fashions and more out at the edge. And when it comes to something like AI, right, it starts off being built in some large frontier lab, right, and then trickling down and proliferating really with the help of open source into all of these different environments, into places where it can work offline, into places where it can work in constrained hardware, and that's really only something that's going to just continue to increase over time. If you think right now of like the size of something like Claude or Chat GPT, right? It takes this massive data center using I don't know, not yet gigawatts of energy, but in the future gigawatts of energy, right? And what you'll see over time, right, is that run in smaller and smaller form factors. You'll see smaller models, right, be able to produce some of the same results, and that really opens up so many more use cases. When I think of airlines, right, I think of intelligence on the planes, right, looking at the every sensor that's on the plane, right, and making smarter decisions around fuel flow and just other things in avionics. Things that people have been trying to do for a long time. It's just really challenging, especially when you get into like the upper atmosphere where cosmic rays become an issue, right? And hardened equipment, and that also extends into space, right? With what we're doing on the ISS and other environments, and in healthcare, it's things that used to be really large devices in hospitals because that was the only place they could be afforded. Eventually those will be able to go and visit homes, right? Or will be resident in a home, providing better feedback on somebody's health. Leads to like much more rapid diagnostics and just better results in the real world. And I always loved seeing technology results in the real world rather than just from like the cubicle wall.
Dude, this is a great segue into the next section of the show. Because yeah, well, again, we had a preparation call, and one thing that really highlighted to me personally from that call is that you mentioned that the majority of the AI projects fail, and especially coming also from the customer side of things, I'd love to get your take on that. Like, why do you think that is?
So at the start of a new kind of technology wave like this, everybody's trying to figure out what are these capabilities, how do they apply to scenarios that we have, right, to problems that we have. And some of it, right, is finding kind of technology market fit, where people are really learning about their own problems. Maybe they roll something out and realize, oh, our data isn't good enough to actually solve this yet. Now we know what we need in the data to be able to solve this sort of problem with AI. And I'd also say all of the tools kind of evolve along with the understanding of the problems. And part of what we do at Red Hat, right, is we work directly with customers, figuring out what those problems are, and then working in upstream open source to actually solve those if it's not something that the technology can solve right now. So the technology kind of improves to where the problems are, and the problems and people's understanding of the problems also improve. So same with their data collection, pipelines, and everything else, so that we can solve those. On top of like the rapid advancement in capability in the AI space.
And do you also think that, like in introduction, we just talked about how everything nowadays is called AI, but like I mentioned, we have a ton of experience already in different fields of AI when it comes to those computer vision workloads, to traditional machine learning workloads. Do you see that, like when talking about AI projects fail, it's kind of more of the modern conversational AI related projects that fail, or do you see, or do you take that more as a whole? Like you see the aggregated kind of type of project fail.
Well, so going back, like we've had expert systems, right, using symbolic logic and things like that in the in what we'd call the AI space in healthcare for a long time, right? Prior to what was the first AI winter in the 80s and 90s. And so I think healthcare has actually been pretty successful with AI over time using some of those traditional techniques, right? Machine learning on imaging, computer vision, expert systems. It's just that they didn't meet some of the initial promises, but there's kind of been a slow growth of success for those techniques over time. The thing that's been new in the past like 10 years, right, is neural networks with backpropagation and all the techniques that we have in AI right now. And I think those are the ones that have been failing at pretty a rapid pace, but they've also been great learning experiences for organizations. So I think a lot of companies I talk to expect to spend some money on these things, expect that experimentation and innovation has a cost, and that's something that's worth bearing because the eventual result is going to be worth that investment.
And when looking at the kind of the cost for the failure, like there's like looking at AI platforms as we build them, we implement them, we tune them for customers, and there's a ton of different reasons why projects could fail. One thing I really like about the Red Hat approach is that you deliver a platform. It's not just kind of a point solution, if you will. Like we're not just talking about an MLOps pipelining tool or talking about GPU observability or whatsoever. It is a platform. So when talking about that failure, do you think that can be solved by the platform approach? And if so, why does that approach then matter? Like what's from your perspective the massive added value of platform versus point solutions?
So at first I'd say that the failures that we're seeing in the healthcare space are really a failure to achieve an estimated outcome. And the failures that everybody is really always hesitant and wants to avoid, right, are data leaks, things that are public, right, things that harm somebody's health, because we deal with so many sensitive things in the healthcare space. So we're kind of always slow going, and the things that we do are usually start off internal in smaller use cases, and they start off with less sensitive data, and over time we kind of want to ramp those up, and that's where Red Hat kind of comes in with what we do with OpenShift AI. The vision there, just like it was with Linux and then with Kubernetes, is we look at the whole ecosystem of open source and say, for Linux, for example, what do we need from a kernel to package management to systems management, right? And how do we combine all of that in some way that works for an enterprise? And that's kind of always what we did with Linux, right? Threw in everything from like just a default security posture with SE Linux. And then we did the same thing with OpenShift in the cloud native space. So everything on the CNCF landscape to figure out how does this translate to enterprises based on the types of problems that they have to solve and the stability that they need over time. And that's kind of what we're looking at in the AI space is what kinds of problems are people trying to solve with this? How can we do that in a way that we can support and provide some continuity as the technology changes so rapidly?
Yeah, we'll dive into the anatomy of OpenShift AI next. But before we do, I really like to get to know a little bit about the history because, OpenShift AI might kind of sound like a new product, but it actually isn't, right?
Yeah, so we've had our upstream open data hub for quite some time. I think that's been around for 7 or 8 years. And from there, we kind of launched what we called OpenShift Data Science, which was really our first pass at this before everybody was calling it AI. And the idea there was how do we help people manage and train models, right? Augment them with other proprietary data, right, that you may have within your company walls, and then operationalize those. And that's really kind of extended in newer AI era to how do we run large language models across this in addition to those custom models. I think the vision that we see across all of this, right, is that the amount of AI that companies are going to use in terms of models is only going to rapidly increase over time, right? And it's going to be a mix of your custom stuff, things that you get from vendors, things that you run as SaaS via APIs, and how do we manage all of that kind of for the enterprise to solve so many different scenarios?
So, how many of the customers you talk to are you actually seeing training their own models instead of like? So there's in one of the previous podcasts we had a really kind of a conversation about what training really means, and quite often it's being misused. A lot of customers we talk to are actually not training. They when they use training, they kind of mean rag, and other customers when using the phrase training, they take a foundation model and just tune it with additional information and make it more kind of suitable for what they're doing. And then there's real training. So what is it that you actually see at customers?
So some of the real training scenarios that I've actually seen over the past, say, almost a decade, right, are for detection and diagnostics of sepsis, right, using all the data around hospital beds and things like that. I've seen people train their own custom models off of like insurance claims data that we have in the US, where you could look at all of this claims and say, based on this pattern that we see for this person of treatments that they've had, it's likely they may have a heart attack in the next 2 years. So maybe we go and start to invest a little bit more in that person and give them proactive treatment to reduce massive costs later. So I've actually seen, for example, that was a model that people started, that company started building about 10 years ago, right? That's only gotten larger, and that was before, like that really wasn't language based, right? That was based on all of this data and like traditional machine learning. Wow, which sounds almost like a legacy term now.
Well, and that's also kind of the one of the misconceptions, right? So you mentioned the Turing test at the beginning of the conversation, and quite often people think that the Turing test is relatively new, but it isn't. Turing invented the test, and that was somewhere in the early 50s, I think, when he actually invented that test.
I forget the exact date. That it
Yeah, I
certainly,
think it was
but like
like
that for a
51 or
long
52.
time,
Yeah.
that had always been, the standard for what at the time like we would call AGI or super intelligence. And now
Yeah.
we're really starting to define the meanings of those things in a more granular fashion.
Now let's dive into the anatomy of OpenShift AI, because what I really like about the solution, it's not it's not a kind of an opinionated stack, if you will, that you can deploy. Well, no, let me take one step back. So what I like about it is you deploy an operator, the whole stuff gets deployed, and it's there. And of course, you created some kind of opinionated stack, but you also deploy it. It's fully tested.
Yeah.
Instead of, you offer a opinionated stack that you have to deploy all of the individual components and projects yourself and then tie them into each other. And kind of what you mean is that, well, in that case, everything is tested in our lab, and we can support it if needed. But you chose a different kind of a different route. So, what is OpenShift AI? And let's look under the hood. What is
Yeah.
it actually made of?
So starting off with, say, like that deployment scenario, right? So like that's the simple scenario. The more complex scenario we see with, say, larger enterprises is you need to deploy this across multiple clusters. You need to have consistency for those things. It needs to fit into DR scenarios, and you need like upgrade paths so that you can manage it over time. So those are like some of the table stakes for us. And we kind of do that like using, so first off, like we use OpenShift as our platform for building these things, right? So OpenShift AI is built on top of OpenShift because these are the tools that we use internally. Like we eat I'd say we drink our champagne. We also eat our dog food, right?
Yeah, yeah, yeah.
When things are new, to get them to taste better. So we build on top of these things. And it includes a range of stuff like you talked about. First is at the bottom of the stack, right, is hardware enablement, right? We have, the drivers for every kind of type of hardware under the sun, and we work with manufacturers like NVIDIA, so we have day zero support for new hardware that comes out. And the idea there is first, we want to make sure that as people come up with a deployment for AI, right now they're using, say, new hardware that they'll buy for that project. Over time, they may add some additional hardware to it. Things may get a little bit more heterogeneous, right? And I'd also say that I think a fair assumption is more vendors will be shipping hardware that people can operationalize AI on. So we want to make sure that people's models and application kind of workflows that they build on AI work across that over time as that changes. So hardware enablement is a big part. We do a lot in terms of optimization for that hardware. So the vLLM project, right, optimizes a lot of open source models to run very efficiently on that hardware. We see savings of like 40% in a lot of scenarios. And then the LLMD project is how can we run a large language model across Kubernetes, right? So what traditionally now is one large application workload, how can we distribute that right to this range of hardware? Then it's all of the things to make that model usable within a company, right? So can we do something like model as a service, which is big for us this year, of allowing people to deploy a model, run it across this range of hardware, then provide quota management, provide gateway access for controlling who can use it. And then on top of that, right, all the tools for building applications on those models, right? So we've been using Llama Stack and a whole range of things in the open source world that are really emergent right now. So though, like tools to build agents and everything else are kind of rapidly changing. Um, Protocols like MCP or agent to agent are kind of rapidly evolving as well. So we take all of that, make sure we have a really solid security foundation for authentication, authorization, right? That it fits in like a zero trust type of environment, and then, right, enable developers to actually build on it. Aside from even developers, it's then how do we take a whole range of different models? How do we help people build models? How do we help version models? How do we help people tune models? All of those things are kind of within OpenShift AI. And each of those really are different upstream open source projects that we work in and then tie together in this cohesive platform.
Well, that's a mouthful. And there's a couple of things that really come to mind. You mentioned a large number of different components. And looking at one of the themes today, healthcare. If you look at those components, what components matter most to healthcare specifically?
So the folks in healthcare that I talk to a lot, I kind of care a lot about those clinical use cases and those things that really affect and improve health. So a lot of that has to happen first with offline access. You can't run a hospital that's completely dependent on an internet connection, right? Things need to still work when that's offline. So I think for like a lot of those scenarios, people need things that can run on premise in their own data center, which means they tend to have constrained hardware, and the optimization of all of that is really important to them. And then I think from an accessibility standpoint, it's how can you deliver all of that and make it easy so people can build on top of it and utilize it to build things that solve problems.
You mentioned vLLM and LLMD as two of the projects which are really supported. Let's dive into that a little bit. So, let's start with vLLM. Why vLLM? Where there's multiple different inference services out there. So, what's the benefit of vLLM?
What I've really liked about vLLM is that it's not just Red Hat. that's supporting that. I think we've had a really large industry push towards using kind of that as the standard. So it's getting a whole lot of support around what hardware it can optimize for, and then a huge amount of work goes into testing every large open source model and quantizing it and running it efficiently in vLLM. So I think it's got kind of the best momentum in terms of the market, and then that results in good footprint for the hardware that it supports and good support for all the models that you would run on top of it, on top of like documentation and good public examples to make it easier to use.
But like, if I would like to, I could deploy it on a Kubernetes cluster right now already. I can deploy a vLLM instance on Kubernetes. So what's the main benefit of using LLMD instead of vLLM when it comes to that cloud native cluster?
I think LLMD really just comes down to scale. So, so right now, people are starting out, and even healthcare companies, right, are starting out with exploratory projects. They may stand up a cluster with a few GPUs, but as we're talking of getting to clusters in the hundreds to thousands or tens of thousands of nodes, clusters that are distributed across different like physical footprints, I think LLMD kind of becomes the way to take that one model that you can't run on a single node and spread it across a range of hardware.
And like without having to invest in hardware that supports GPU linkage over the network, and so this offers kind of the software approach to hardware limitations, if you will.
That's right. Yeah. So vLLM, it's like to be more concise about it. VLM is really good for running on top of a single node. That's kind of the purpose of vLLM. LLMD takes a large language model and spreads that across a whole bunch of nodes. Where if you have a model that's in the hundreds of billions of parameters or trillions of parameters, you're going to need a lot of GPUs and a lot of physical nodes to be able to host that footprint.
Cool. Now let's talk use cases a little bit, because you shared kind of the anatomy of OpenShift AI. So what are some of the top use cases that you really see at customers?
Well, people have been using like computer vision for quite some time, and I think those have gotten just better as people have been pouring more money into like the AI ecosystem. Now it's everything around large language models, and what I've seen are like real-time transcription for doctors' visits, right? So kind of the ambient note taking is really good for the clinical setting of saving doctors and nurses time and pushing more of that work off to the AI. And that's really something that's going to be taking off over the next year to 3 years. You'd see kind of better imaging in terms of like MRIs or anything else, where the language, or not the language models, but the machine learning models are really kind of interpolating all the other positions and getting more precision with less time that people would have to spend in the MRI to get that, which is kind of cool. I think they're better at finding patterns in diagnostics for that image recognition itself. That's pretty cool. And then like there's all the administrative stuff, which is how can we save money and operate more efficiently, right? In taking calls, in triaging problems, in just eliminating overhead burdensome processes. Like in the US, we have something called prior authorization, where before a doctor can treat you for something, they actually need to go to the insurance company and confirm. And there's some back and forth around policy and everything else. And we're automating a lot of that with AI and even agents running in companies. So that reducing the administrative burden of healthcare, I think, is really important, and really kind of also leads to just a better experience with the whole system, at least in the US.
Yeah. So, we talked about, imaging, computer vision, also looking at a different use case that we had a brief talk about before the recording, was around models as a service. Like, what are you seeing from that perspective at customers? Like, I know the conversational AI use case is, is a broad one. But when it comes to just offering models as a service to the organization, what is it that you see in that perspective?
Well, so the idea there, right, is how can we run something on-prem rather than just using something in the cloud? And models as a service, right? The idea is, you can deploy this and get reuse out of it. And that's always been kind of a goal of software and software architecture, right? To get the best reuse out of something. So with, say, models as a service, it's rather than each application having deployed its own model, right? Can you deploy one model, have each application do its own RAG or tuning on top of that, and then provide the right gateways, the right access, everything else around that model. And I think as on-prem models kind of proliferate in the next couple of years, model being able to operate those as a service internally is really important for companies.
So when it comes to, again, the anatomy of OpenShift AI, and specifically talking about model as a service, I mean, like, you mentioned vLLM. So there's an inference server. We can populate the API at the outside of the platform. But what other components when talking about MLOps, or you mentioned MCP? So like, is there a kind of a set of solutions that customers can use right away to start building their own stack and extending it using MCP or A2A? Or how does that kind of like work for a potential new customer in healthcare who wants to potentially use OpenShift AI?
Yeah. So our vision has always been, here's an opinionated view of this stack where you can pull out any individual component, right, and use what you may prefer. And that's it's a hard platform to deliver that way because you make everything modular and pluggable. But it's worth it to fit into all of these environments. So people that are starting new, we want to give that kind of that opinionated view of it, right? So here's how we do model deployment, right? Here's how we do model as a service. Here's how we do gateways on top of that for accessing those models, or how you would provision access tokens, things like that. Just kind of like the guardrails for then how you would, review data coming into that model, review data going out of that model. All of those things are kind of important when it comes to those enterprise use cases. They're usually less important when people start building a POC, but when they want to operationalize it, we've seen scenarios, say in the US, where somebody was negotiating with a car dealer or an insurance company, and they get them to cover something or sell this car for $1. And then, like, contractually, the company actually had to live up to that. So those are interesting scenarios, right? And it's, how can we roll out this sort of capability and provide the safety that you can say that your business will rely on it, right, without it obligating you in some way, or really harming somebody, especially when it comes to medical scenarios, right?
Yeah. No, and I fully understand. It's especially looking, for instance, at the kind of the RAG use case. Quite often, we see a customer just deploying and this all comes down to why projects fail as well. I want to have a RAG solution. I'll deploy it as fast as possible. I'll take something off the shelf, or I'll just download some, open web UI application with an inference server tied to it, and pull a model, and all of a sudden I'm done, right? But
Yeah.
especially looking at large customers, large enterprises, you mentioned Guardrails. I think that's one of the biggest risks we see, like not tying the right guardrails around the model, but also looking at hallucination. It's not having the right tools in place to prevent hallucination is is definitely one of the reasons why projects fail. So, like, looking at hallucination, is that something that can be can we reduce the risk of hallucination with some of the tools in OpenShift AI as well?
So hallucinations is an interesting problem, and it, like, as we look at domain specific uses of AI, people tend to get a lot tighter in what those guardrails are. So, like, the possibility for hallucination becomes just smaller because you can't ask the model around about a whole range of different things. So I think that's kind of key in hallucination for some of those enterprise use cases. I think another big part of that is what data is in the model in the first place. And this is a challenge right now. And I think it's going to get better over the next couple of years. So fundamentally, the all of the data that's in your model, right, is like think of it like security footprint. It's think of like lines of code. The more lines of code you have, right, the more potential security vulnerabilities you have. If your model knows about alcohol or, weapons, right, it should never be sharing that information to kids, clearly. So ultimately, we want models that are as small as can be, that contain only relevant data to use cases. But they have to have enough there to actually understand language. And that's where like the hallucination problem comes in. Certainly with even large models where you ask them around so many different things. And I think it's something that hasn't really come as strongly to the open source community because it hasn't been a problem that at least in the scenarios that open source has been trying to address. It's more a problem for those frontier labs who are kind of trying to solve every problem at once. In terms of open source, we want things that are a lot more targeted right now, and that really fits the enterprise scenarios better. Um,
Yeah, and
it,
it's fun that you mentioned the hallucination of the frontier models. I've been playing around with codecs from OpenAI and quite recently Claude Code. And one big difference I see between the two is as soon as my context window of Claude Code becomes too big, it starts compressing. It's probably starting to create kind of a summary of all of the different completions and the prompts that were tied into my context window, compress it with the result that I haven't detected any hallucination so far. Whereas
yeah,
with ChatGPT and Codex, it's as soon as the context window gets too big, oh dude, it's berserk. I try to let it troubleshoot a Kubernetes cluster I was building, and it suddenly it suggested all sorts of challenges that or solutions to solve a problem that was not there in the and with so far with Claude Code that hasn't happened. So I'm honestly I'm surprised how the different frontier models and the services tied to it kind of handle the challenge of hallucination. But
yeah.
yeah, definitely an interesting challenge to solve in the future.
So one way to think of it right now, like if you were building something, say super intelligence, we want these things to be able to solve all these problems and not hallucinate. It's like we've built a brain with only one portion of the brain, right? Our
Yeah.
brains have a lot of different pieces of them that do complementary things, and we're still trying to understand what are the complementary pieces that we need to be building to solve problems with AI.
So, the last topic around the use cases and kind of the anatomy that I wanted to dive into is everything around operations, cost control, observability, because I'll be going to KubeCon in a couple of weeks from now in Amsterdam, and one thing to me that really stood out is the number of projects and startups focused on observability and specifically FinOps. It is insane how many FinOps startups have emerged from nothing because last year they didn't exist yet or weren't big enough to sponsor the event. But I um, and this is one of the things I dislike about the CNCF landscape, especially looking at all of the different aspects of observability. Looking at the landscape, it makes me, it gives a headache. It's
Yeah.
that simple. There's so many different projects to choose, and I'd rather not. So, what do you guys do when it comes to that part of the stack?
So I was at KubeCon in North America a few months ago, and you're exactly right. Everybody is trying to look at all of the data that we have for operational systems and then make intelligent decisions on that. some of those, right, most of those, funny enough, most of those are entirely cloud-based rather than things that can run on-prem. And some of that is just for speed of iteration. But I'd say in general, it's going to be table stakes that systems get more intelligent. That means easier to set up, easier to use and discover features for administrators. I think systems are going to need to introspect all of the data that's coming into the system and either make automated tuning where possible or suggestions for, I see an upcoming failure. Do you want me to prevent it by running this tool? I think that's kind of going to be table stakes. And right now, right, everybody's saying, okay, this is now possible. It's operationalizing it in these systems in in different like scenarios where, or say different hardware footprints in different scenarios. All of that's kind of be really coming over the next couple of years. But part of that, say, if you want Kubernetes to be, self-healing in that way, it means almost every cluster is going to need some amount of hardware to run language models, right? Not everybody right now even has GPUs to do that. So, so we look at things like, can we make OpenShift smarter and can we prevent problems when running a language model just on the CPUs that you have in your nodes, right? That's something that even comes down to vLLM. So yeah,
Um,
that's going to be a
yeah,
big
and
topic next couple of years.
let's dive into that future topic because I heard a rumor that OpenShift 5 will bring, like you mentioned, a lot of those features, maybe some more focus on the intelligence side of things. So looking at kind of the road ahead, and you mentioned a couple of things already. Are there things you are allowed to share already? That listeners, viewers should be looking at
Yeah.
and should be following you about.
Well, I can't share much about OpenShift 5, but yeah, we have a announced intent to release that. So next year that's going to be, or actually this year that's going to be a big topic. So look for more from Red Hat for that. I'd say that like part of to recap some of what we've already said is that we're going to need to run more AI. We're going to need to run it on a range of diverse hardware. People are going to be shipping more hardware that's capable of operationalizing these things, even if it's not the latest NVIDIA GPU. Most people don't actually need that to run the kind of AI that they need to solve business problems. So we're going to be seeing people be able to solve more with AI, and we're going to really see just a I don't know if I'd say an exponential increase in the use of AI, but the idea is that we're headed towards a abundance in the use of AI. So even now, right, it's if we had say 10 times as much capacity, we'd be wanting to roll out 20 times that. So that's not slowing down at all. And the challenge for us and what we want to do at Red Hat, right, is kind of meet that hardware moment and bring all the software that makes it possible for people to use that in enterprises.
So let's dive into the last section and start with a kind of a shared recap. And if you are okay with that, I'll go
Yeah.
first because a couple of things I learned today, and some I already knew, but I really love the kind of the platform approach. I like the fact that the entire platform is definitely suitable for highly regulated environments where um, there's a large variety of different use cases demanding a ton of resources and flexibility from a platform. Now, I think that to me kind of sums up what Red Hat can offer with both OpenShift and OpenShift AI. Did I miss anything from your perspective?
I'd say a good part of that is extending it to the cloud. So even for those scenarios where you don't have hardware or the data center, can you run the same thing in GCP or Azure or AWS? And that's part of what we do with OpenShift AI as well. And when you think about each of those, right, they each have their own custom silicon for doing those things, right? So what you want, right, is an application that can work across all of that. And then you can, if you actually make an investment in hardware, right, that you can use it there too.
And
So
that's one of
that's
the interesting. Well, this is one of the interesting topics that we obviously haven't talked about. But yesterday when we had the other conversation, one thing you mentioned is like, so you know, healthcare is broad, especially looking at healthcare in the entire globe. And one big difference, I guess, that we see in this side of the pond is that you just mentioned cloud and all of the cloud extensions that OpenShift supports and all of the cloud locations, right? So we see a massive, well, I won't say exodus, but we see a lot of customers moving their cloud workloads, especially when they have no idea where it lives, or at least move the data out of the cloud to something on-prem. And as far as I know, the majority of hospitals that we work with don't even use cloud for medical data. Is that
yeah.
something that you see differently in the US?
Oh no, actually the key trend there, right, is we call it sovereign cloud, right? That you want to really own the things that you're critically dependent on. And that applies not only to like nation states, right, but to large companies as well. People want to be autonomous, and organizations want to be autonomous. They don't want to be so interdependent that, some policy or regulatory change in some part of the world can shut them down in an instant. So yeah, sovereign cloud is a massive push for us, and a big focus right now.
Which means
That's
when
kind
you
of
talk
always
about like, yeah, so
uh,
if you mean like if you look at multi-cloud platforms or multi-cloud environments, then I can imagine that everything that's not directly talking to your data or isn't tied to those strict regulations can still live in a public cloud, but just then using the same platform as you use on-prem. So you have
yeah,
one general overview, you have one management console, you have one way of managing everything.
that's right. So that's always kind of been the vision for OpenShift, is how can we let people bring, the capabilities that they want from cloud, right? The self-service, the auto scaling, the ability to roll out new software, kind of a platform engineering approach to managing and building all of that, and abstract the location of that. So really, that it's only becoming more important as we talk about sovereign. It's say, can you operate all of this stuff with your own capabilities and then burst to cloud, right? That's been something that's been talked about for a decade now,
Yeah.
and that we always kind of targeted with OpenShift, and now that is the same thing for AI, right? Can you run the critical functions on-prem and then have nice to have or non-critical functions, right, run in cloud or some other location, and maybe even move those dynamically over time.
Definitely sounds like a topic we could follow up on in a future conversation. Talking about the future, I have one final question before I let you go. Because hypothetically, if I would invite you back in a year from now and maybe talk about the topic of multi-cloud AI environments, um, what would, from your perspective, will have changed most in AI, maybe specifically in healthcare?
So first, I'd say everybody's power bills are going to be going up, which
Ha!
which is it's so that's one to look out for, right? That's the big problem that we have that's underlying all of this stuff. That as we use more of it, we need more power, we need more capacity to run it, and that kind of is at odds with a very sustainable world and a sustainable environment. And I'd say in the healthcare space, you'll see a lot of improvement in clinical operations. You'll see a lot more ambient AI. You'll start to see more devices for for home use. I think right now, maybe our phones are listening, but people will start to have devices specifically for AI that are basically recording and tracking all of these things, including vital signs and health statistics. We have, Apple Watches and other wearables right now, but the capacity of those things is gonna rapidly increase. There you go.
Yeah. So
That-
you mentioned ambient AI. What is that actually what you mean with it?
that's only part of it. I
Ah,
think so. Right now, right, you talked about Claude as something that you typed into, and it maintained that context window. What's going to start happening is they'll have a context window for you based off of audio or any signals that you want to share, right? So if you're wearing a device that records every word that you say, that's a lot of context about you.
Right.
And even further,
So
that, we'll run into scenarios where you need to separate the work context of you versus the personal context of you, and that'll be a future security challenge.
I guess so. Again, something we might be able to talk about in a year from now. Oh man, Vince, I really enjoyed this conversation. It went all over the place, but I think we definitely covered most of the questions that I had up front. So if people would like to follow you in all of the adventures that you have, what should they do, or where should they go?
Well, certainly always email me at vince@redhat.com. I'm on LinkedIn. I do a lot of Red Hat events. So we do our Red Hat Summit. It's going to be in Atlanta, Georgia, in the U.S. in May. That's a pretty big event. We have people kind of fly in from all over the world there. So if you come to that, reach out. I'll be there. I do a lot of other regional events for Red Hat, and just email me or ping me on LinkedIn.
Awesome, man. Well, thanks so much for being a guest, and we'll definitely talk another time.
Thank you, Johan.
Thanks for tuning in to the Private AI Lab. Don't forget to subscribe on Spotify, Apple Podcasts, or YouTube, or to the newly announced Private AI Lab newsletter on LinkedIn. And visit Johan.ml for more insights and experiments. Experiment complete. Until the next one, stay curious.
Private AI Lab.